Hi everyone, we are Team B2 and we are here to introduce our project iRecruit, an interview assistant that is about to make your interview preparation process a whole lot easier. Just like our peers, the three of us have been through the recruiting process and know how stressful it can be. We know the time and energy it takes to prepare for interviews in order to be able to do well. Currently, there exist many resources such as books and websites that allow you to practice questions and give you tips and tricks on how to do well. However, we found a lack of resources that allow users to practice simulated interviews and get real-time feedback on a centralized platform. This is how we came up with the idea for our Capstone project. iRecruit is an interview assistant that is capable of providing software engineering job seekers the chance to practice simulated interviews. Users can practice both behavioral and technical interviews and get real-time feedback. This is the home page of our web application, iRecruit. On the top right, we have two buttons, one to register if you do not have an account yet, and one to log in if you do. And because I do, I will log in as user 14. Once you log in or register, you are led to the dashboard page, which we see on the screen right over here. Throughout all our pages, we have two navigation bars, one on the top and one on the left, to allow easy navigation between all the pages on our web application. Starting from the top right is a tips page. On this page, we go over behavioral and technical interview tips. To the left of the tips page is the profile page. On the top left of the page is the dashboard page once again. We provide three buttons to allow the user to immediately start practicing behavioral or technical interviews, or to be able to go to their profile page and view past progress. On the left side of our page in the navigation bar, we have three buttons. The first two buttons also provide easy access to start practicing behavioral interviews or technical interviews. And lastly, we have our logout button.
The behavioral interview portion aims to provide real-time feedback to users on subpar eye contact and/or screen alignment while the user video records themselves answering a behavioral interview question. This involves facial detection through using the OpenCV library in Python. For the eye contact part, we use HAR cascades in OpenCV, which are pre-trained classifiers for features such as the face, eyes, and smile. For each frame of the video, the system uses the frontal face HAR cascade to detect the user's face and the eye HAR cascade to detect the user's eyes. After the eyes are retrieved, we track the irises and pupils within the eyes using a blob detector in OpenCV. If the user's eyes are moving around, we alert them with a pop-up message within 5 seconds. For the screen alignment part, we use HAR cascades and facial landmark detection through the FaceMark API. Similar to the eye contact portion, we use the frontal face HAR cascade to detect the user's face. After the face is retrieved, we use the FaceMark API local binary features to determine the locations of all landmark facial features. We then pinpoint the coordinates for the center of the nose and mouth to use for our screen alignment detection. If a user is off center of the screen, we alert them with a pop-up message within 5 seconds.
The behavioral interview page has three options. The first option is to practice both eye contact and screen alignment at the same time. The second and third option are for eye contact only and screen alignment only respectively. This way, the user can choose what they want to focus on.
So here is option 1. So the steps I usually take before making a decision involve making sure that I completely understand the prompt at hand and that I have met with my team so that we have established a clear process and also a clear design architecture for the product. And I think that transparency is really important so that we all communicate well and work well together as a team. And here is the second option. One time I had a setback was during my freshman year internship where I had to automate a service and I ran into issues with linking an email to AWS because of security issues. So then I was able to figure out that we had to use an AWS S3 bucket, and here is option 3. My most stressful project was probably a HTTP server that I had to build for my computer networks class. And this was difficult because I had to brush up on a lot of C concepts for the programming language that I was still pretty unfamiliar with. Able to meet or exceed all of our accuracy requirements for the facial detection part. For the first requirement of initial setup, we are able to learn the user's facial features within 5 seconds. For the next one of alerts, we are able to alert the user of subpar eye contact or screen alignment within 5 seconds. For option 1, for both eye contact and screen alignment, our accuracy was 84.91%. And for option 2, with eye contact only, our accuracy was 87.04%. And finally, for option 3, our accuracy for screen alignment only was 98.04%. All 3 of these options exceeded our requirement accuracy of 80%.
The speech recognition algorithm is split up into the signal processing and machine learning components. The goal of the signal processing part of our project is to represent the user's audio recording in such a way so that the representation is similar for the same words and varies for different words. This is done through saving the audio file, applying a Hamming window to 20 millisecond chunks, and taking the Fourier transform of these chunks to represent the data by its individual frequency components. Then, in order to reduce the dimensionality of this, we applied the Mel filter bank coefficient approach. The results are plotted on the spectrogram above. It can be seen that the representation looks visually different between different words.
Second part of the speech recognition algorithm was a machine learning algorithm, and we decided to use a convolutional neural network for this part. Just to give a high-level overview of our neural network, we have 3 layers. The first layer, or the input layer, is a feature vector of length 1500, which we retrieved from the spectrogram of the signal processing output. The second layer, or the hidden layer, has 4 hidden units. And finally, the last layer, or the output layer, is a vector of length 8, representing the probability distribution over 8 classes, each class representing 1 word that the user can speak for our speech recognition algorithm. The alpha matrix holds the weights to compute the hidden layer vector using the input layer, and the beta matrix holds the weights to compute the output layer using the hidden layer. We run this algorithm 100 times or over 100 epochs in order to find the optimal parameter matrices to minimize mean squared error. In terms of our requirements for our speech recognition model, we were not able to meet all of them. For the signal processing aspect, where we took an audio file and processed it in order to represent it as a spectrogram, this was successful because the same words spoken by the same person had the same spectrogram representation, which was what we were going for in order to create our training data for our neural network. However, when it came to the classification accuracy of our neural network, our goal in the beginning was to achieve an accuracy of 65%, and at the end, we achieved an accuracy of 35%.
This is how the technical interview practice page looks like. When the page is loaded, the user is presented with the 8 different categories that they can practice from: arrays, binary trees, dynamic programming, Java, linked lists, Python, recursion, and strings. To record their choice, the user presses the play button. This triggers the speech recognition algorithm in the back end. And so now I'm going to press the play button to record my choice. Java. And so this is the spectrogram representation of Java. And then once I close this, my neural network will start to run. Once the algorithm is finished running, the output is displayed under the chosen category banner, and the question from the category is displayed under the question banner. So I said Java earlier, and the algorithm correctly detected that I said Java. And so now I can answer this question below, name the 4 access specifiers in Java. And so the answer is public, protected, private, and default. And then if I press submit, so you can see that the correct answer is displayed alongside the user's answer, so that the user can determine the correctness of their answer. This design choice was made because some of our questions are open-ended. From here, we can navigate to the profile page, which we can click on.
Once on the profile page, we can click on this button to view completed behavioral interview practices. iRecruit stores a summary of the results from behavioral interview practices. This includes the option the user chose, the timestamp of when the recording occurred, the number of times the user had subpar eye contact, and the number of times the user had subpar screen alignment. For the eye contact option, the subpar screen alignment count is not available, and similarly for the screen alignment option, the subpar eye contact count is not available. So if we scroll down, we can see the previous 3 recordings that we did for each of the options and the summary of the results.
To view a summary page of technical questions and answers, we can click here. So for technical interviews, we store the question, the correct answer, and the user's answer for each practice run for the user's reference and convenience. So I'm currently logged in as user 14, and so this is a list of the technical questions that user 14 has answered, and it updates in real time as more questions are answered. So previously he had answered a question about a linked list, and then just now we came across this Java question. And so if I want to delete a question, it's perhaps so that I can answer it again in the future, I can do so like this, and it will not appear again on the page.
And this has been iRecruit. Thanks for watching.